Okay, so for problem 6.5, we are asked to compare the savings per machine per hour from two different options. One option is with a constant amount of hours per year, and the second option with varying hours per year. So for the first option, it says that the robot will be operated for 2,000 hours per year. So first I had to look for the present worth. So I set up the table and I used the formula for the compounded formula, solving for P. So for my P, I used the investment of $1 million. For my N, I used the periods, the corresponding periods for each row. And then for I use the 15%. So I set up my formula, I drag it down for all periods 1 to 5, and then I add them up to get the present worth with a 15% rate. Once I got that, I set up a second table using the capital recovery formula, and I set up my P to be the present worth at a 15% rate. For my I use the same 15%, and then for my N, I use the corresponding N on the table for each row. I drag down the formula and I got a total of $260,516. And then for the savings per hours, for this option, I basically divided the annual equivalent of $260,516 by the hour usage stated on the problem of 2,000 hours. And I got $108.26. So for option B, we have the hours varies depending on the period. So I use the same formulas, but to find different values and these values represent the savings, the hour savings. So for the first column, for the present column, I use the compounded formula. I used as my P the corresponding hours for that period. For my N, I used the corresponding period for that row that I'm looking for. And then for my I use the interest rate of 15%. So once I got set up that formula, I drag it down for all 5 periods, and then I add all the present hours, and I got a value of 6,727.77 hours. Then I use the capital recovery formula to find basically the annual equivalent of savings by the hour, because as for this formula we are calculating just hours, we are not talking about dollars, this is all for hours. So like I said, I use the capital recovery formula. For my P, I use the pH as I set it up in the formula at the end, for my pH value of 6,727.77 hours. For my I use the same 15%. For my N, I use the corresponding period for that row. And then once I set up that formula, I drag it down, and then for the last period, I got a total of 2006.99 hours. So to find the savings per hour per machine in this occasion, what I did is I divided the equivalent of savings by the equivalent savings of hours. Why did I do that? Well, since it's on the statement, we are using the same conditions, the same initial conditions for investments, for the period, for the salvage value, for the inflow, outflow. We are using all the same conditions for both cases, and also for both cases, we have a total of 10,000 hours at the end of the periods. So because of that, we can use the equivalent of dollars savings to find the machine per hours, the savings per machine per hours for case B. And for my total, I got 107.88 dollars per hour. And if we compare both alternatives, we can conclude that for case B, it generates 0.38 less dollars savings per hours in comparison to case A. Now for the second problem, we are comparing the current we are comparing the current supplier against an outsourcing supplier. So on the first paragraph, everything that is said on the first paragraph is concluded in a table. So we got the unit cost for the current supplier, and then a unit cost with an outsourcing supplier. But then on the second paragraph, we are given some special conditions that are not taken into account on the table for the outsourcing option. So we are asked to find we are asked to find the unit cost for these special conditions. So I got the first table. For the first table, I used the same capital recovery formula, and I set up as my P the difference of the inflow with the outflow. For the inflow, we got the salvage value of $6,000, and then for the outflow, we got the investment of $325,000. The difference between those two is $265,000. So I use that value as my P for the formula. Then for the I use the 18% rate. And then for my N, I use the corresponding N for the row that I'm looking for. So I set up the formula, I drag it down, and then I added all the values to get the okay, just give me 1 second to find the capital cost, to find the capital cost. And we got this capital cost is by an 18% rate. So for the annual equivalent cost, we also need the operating cost, but the operating cost is actually given on the second paragraph, and it's $120,000. So I added the capital cost and the operating cost, and it turned out to be $200,000 $325.93. Then what I did to find the unit cost increments for the special conditions, I divided the annual equivalent cost by the units sold per year, and I got $4.01. So to find the unit cost with the outsourcing option, I just added the $218.50 and the $42 given on the table, with the 4.01 unit cost that we found out, taking into account the special conditions, and it turned out to be $264.51. So we can conclude that the outsourcing option will save $5.49 per unit, because that's the difference between the unit cost with the outsourcing option with the special conditions and the unit cost of the current supplier.